Hello everyone, this is video 2-6 to be watched Wednesday 10-5. It's going to be a very short video, just 2 examples. And the corresponding homework is on page 10 and it's the whole thing, all of it. Okay, so this is on page 13 in your video packet, the notes that we're about to write. And this is just more power rule situations. So this is a continuation basically of the last video lesson. And in order to use the power rule, okay, so the power rule only works if, okay, so I'm writing something to the side. You don't have to write this down, but the power rule only works if functions are of the form ax to the n, or a sum or difference of terms of the form ax to the n. Okay, so if you look at this first function, g of x, this is not written as a sum or difference of terms that look like this, ax to the n, where a and n are constants. But you can rewrite it to look that way. And the strategy is this. You break up the terms into individual fractions. Now this strategy, guys, only works if the denominator is a monomial. Okay, so if the denominator is itself of the form ax to the n, and the numerator is a sum or difference of terms of that form, then you could break it up into individual fractions. All right, so the first thing that I'm going to do before I take the derivative is I'm going to say to myself and my reader that this is the same as negative 6x to the third over 2x to the fourth plus 8x squared over 2x to the fourth minus 8 over 2x to the fourth. Guys, common denominators work this way. If you have common denominators, then you could, rewrite the expression as one big fraction, but it also works the other way. So that's what I just did. I kind of decomposed this. Now I'm going to use the fact that if we are taking the derivative of a sum or difference of things, that's the same as taking the derivative of each of the terms separately. So the next thing that I'm going to do is I'm going to use that bracket prime thing that I was demonstrating. You don't have to do this if you don't want to when you're on your own. And in fact, the goal is for you to do this much faster than I'm about to. But please just do this along with me for the notes. So I have 3 separate terms here that I'm about to use the power rule on. So I'm going to set it up like this. G prime of x equals bracket prime plus bracket prime minus bracket prime. And what goes in those brackets is what I'm going to take the derivative of. And I'm going to simplify it. So this first term simplifies as negative 3x to the negative 1. The second term simplifies to 4x to the negative 2. And the third term simplifies as 4x to the negative 4th. Okay, and now I'm going to take the derivative. This bracket prime notation just means to take the derivative of whatever's inside of the brackets. So I'm about to have our final answer here. So g prime of x, the derivative of the function g at any input x, that's what this stands for, equals, I'm using the power rule, so I multiply negative 3 by negative 1, and I get positive 3, x to the, I subtract 1 from the former exponent, so negative 2, plus 4 times negative 2 is negative 8, so that'll be minus 8x to the negative 3. I just subtracted 1 from the exponent. And then minus 4 times negative 4 is negative 16, so plus 16x to the negative 5. Okay, so there's that, guys. Okay, now we have another one. So here is a situation where, again, we are not working with a function that is a sum or difference of terms of the form ax to the n. But by expanding it, and that's the strategy, to expand, which means to double distribute in this case, if we expand it, it will be an expression of that form. So the first thing I'm going to do is make the observation that this is 10x to the 1/2, okay? That, 10 radical x is actually that. And I'm going to double distribute. So I get that h of x, I'm not taking the derivative yet, I'm not able to yet, equals, so x to the third times x is x to the fourth. X to the third times negative 5 is negative 5x to the third. Now, negative 10x to the 1/2 times x is negative 10. X to the 1/2 times x to the first, that's like x to the 1/2 times x to the 2/2, so x to the 3/2. And if that doesn't make sense, just pause the video and think about that. And then finally, negative 10 x to the 1/2 times negative 5 is plus 50 x to the 1/2. Now I have a sum, I have sums and differences of terms of this form, ax to the n. So I could use the power rule. Guys, I'm not going to do that bracket stuff. This time I'm just going to go for it. So I've got h prime of x equals 4x to the third minus 15x squared minus 10 times 3/2 is 15. X to the 3/2 minus 2/2, which is 1, is 1/2. Plus 25x to the negative 1/2. Okay, there it is, guys. Okay, I'll see you soon. Bye-bye. Oh, yeah, and don't forget the homework, page 10, the whole thing. Okay, see you soon.